Section 3.3, Applications of Linear Programming. Let's use linear programming to solve real world problems. We're just going to extend what we learned in the last lesson into this lesson. Thomas Pinedo plans to start a new business called River Explorers, which will rent canoes and kayaks to people to travel 10 miles down the Clarion River in Cook Forest State Park. He has a total of $45,000 to purchase new boats. He can buy the canoes for $600 each and the kayaks for $750 each. His facility can hold up to 65 boats. The canoes will rent for $25 a day, and the kayaks will rent for $30 a day. How many canoes and how many kayaks should he buy to earn the most revenue of all boats can be rented each day? So let's start that the most revenue. We're looking for maximum. Okay. We're going to let x equal the number of boats and y equal the number of kayaks. At most, he can have 65 boats and kayaks altogether. So the cost of each, so it looks like it costs, canoes cost $600 each, and kayaks cost $750 each, and he has a total of $45,000 that he can spend. And then how much money he makes. So he can rent a canoe for $25 a day and a kayak for $30 a day. So we're going to let our z function, I guess, our 25 equals 25x plus 30y. So we're going to look for the maximum. And we have some restrictions. We know, based on what we have in our table, that x plus y has to be less than or equal to 65 boats altogether. And we also know that 600x plus 750y equals 45,000 altogether. We can simplify that a little bit, so that when we graph it, it's not such large numbers, because each one of these are divisible by 150. And since they're all divisible by 150, we know that 4x plus 5y is less than or equal to 300. So this looks a little bit better. We also want to put the constrictions on that we have to have greater than or equal to 0 canoes, and we also have to have greater than or equal to 0 kayaks. We don't want to have negative kayaks or negative canoes. That just doesn't make any sense. So we have 1, 2, 3, 4 graphs that we're concerned about. And remember that when we have the constrictions of x is greater than or equal to 0 and y is greater than or equal to 0, this amounts to just focusing on the first quadrant. We just want positive values. So going to the next screen here, we can graph. So again, we have x plus y is less than or equal to 65. We have 4x plus 5y less than or equal to 300. We know that x has to be greater than 0 and y has to be greater than or equal to 0. So again, I only have the first quadrant here for us. We'll have to get y by itself so we can graph. So in this first one, we'll have y is less than or equal to negative x plus 65. And this, so we have to graph this one here. And we also have 5y is less than or equal to negative 4x plus 300. So dividing everything by 5. Y is less than or equal to 4/5 negative 4/5 x plus 60. So I go by ones here on my graph, but we're going to have to just go by tens here. Otherwise, we won't have enough spaces. So think of this as 10, 20, 30. So 10, 20, 30, 40, 50, etc. So if I want to graph my top equation, the y is less than or equal to negative x plus 65. We'll go up to 65 and we'll place our point. And we have to go down 1 over 1. As long as we go down 1 and over 1 on all of them, we don't have to go and we're going to have a straight line. And we have to shade below that, so we have to shade in that triangular region. So keep that in mind. We also have y is less than or equal to negative 4/5 x plus 60. So I have to go to 60. So remember we have, and go down 4. 1, 2, 3, 4 over 5. 1, 2, 3, 4, 5. And we will also have a straight line here. And we're shaded below. So we're shaded in this area here. We have a few points that we can take a peek at. So we have this point here, this point, and then we have some point in here we're not quite sure where it is. So we may have to solve in order to determine what that point is. So we have 2 points that we know for sure. We have 65, 0, and we have 0, 60. But we need to know what this point here is. So remember, we can solve using the Gauss-Jordan elimination method, which is what we're going to do right now, to determine what point is that they touch one another. It's not very clear from my graph. So we know that we want to know where x plus y equals 65 and where 4x plus 5y equals 300 connects one another. So I'm going to multiply my top equation here by negative 4 and then add it to my bottom equation. So when I multiply everything by negative 4, I have negative 4x minus 4y equals 260. So my x's cancel. I'm left with y equals 40. Okay, so 40 is my y value. I can find my x value by plugging into our equation here. So x plus 40 equals 65. Subtract 40. So x equals 25. So my point here is 25. My point here is 25, 40. We need to check each one of those with our z function to determine which one gives us our maximum value. So remember, our z function from the previous page is 25x plus 30y. So $25 per canoe and $30 per kayak per day. So let's just start at the top left. So 25 times 0 plus 30 times 60. That would give me 0 plus 1,800, so $1,800. Let's try 25 and 40. So 25 times 25 plus 30 times 40. That would give me 625 plus 1,200, which would be 1,825, so slightly higher. And then the last one, we have 25 times 65 plus 30 times 0, which would just be 1,625 plus 0, so 1,625. So it looks like our maximum value revenue is 1825 when we did 25 canoes and 40 kayaks. Lisa Abbey is a 4-H member, raises only goats and pigs. She wants to raise no more than 16 animals, including no more than 10 goats. She spends $25 to raise a goat and $75 to raise a pig, and she has $900 available for this project. Each goat produces $12 in profit, and each pig provides $40 in profit. How many goats and how many pigs should she raise to maximize her total profit? So here we want to look again, maximizing our profit. We don't know how many goats we have, so we'll label them X. We don't know how many pigs we have, but she knows she doesn't want to raise any more than 16 altogether. We also have a goat limit. She wants to raise no more than 10 goats. We know that it costs $25 to raise a goat, and it's $75 to raise a pig, and she has no more than $900 to spend. And we receive $12 per goat and $40 per pig. So let's start with our Z function. This is going to help us reach our maximum value. We know that we have $12 per goat plus $40 per pig. And we have some equations. We have x plus y is less than or equal to 16. We have x is less than or equal to 10. And we have 25x plus 75y less than or equal to 900. All of these can be divisible by 25 to help us simplify a little bit. So x plus 3y is less than or equal to 36. And of course, we only care about having positive pigs and positive goats, so we want x to be greater than or equal to 0 and y to be greater than or equal to 0 as well. So let's transform these equations over to our next page here. Again, our z function to help us determine how many we get is 12 per goat and 40 per pig. Okay, so we have x plus y is less than or equal to 16. Therefore, y is less than or equal to negative x plus 16. So we have to graph this one. We also had x plus 3y is less than or equal to 36. So 3y is less than or equal to negative x plus 36. Divide by 3. Y is less than or equal to negative 1/3 x plus 12. So we have to grade this one. Notice that I only have the first quadrant because we only care about positive numbers, so that takes care of that x is greater than 0 and y is greater than 0. We also have that x has to be less than or equal to 10. Okay, so I'm going to go by, since we have 16 and 12, I'm going to go by 2s. So we're going to have 2, 4, 6, 8, 10, 12, 14, 16, etc. So 2, 6, 8, 10, 12. Okay, so I want to graph my first equation. So we go up to 16. Up to 16, and we have to go down 1 to the right 1. So down 1 to the right 1. Go all the way across. And we have a straight line. We also know that this is we have to shade below it, so we're in the triangular region. All right, let's do y is less than or equal to negative 1/3 x plus 12. So we go up to 12. and we go down 1 to the right 3. And again, we're going to have another straight line, and we want to graph shade below this line. So both of them were shading below, so we're kind of in a little region below. And then we want x is less than or equal to 10. So here's 10, and when we have x equals a number, it's a vertical line. So the area, and we want numbers less than that, so the area we're concerned about is right in here. Okay. So we have some points in there that we need to take a look at. We have the point 0, 6. We have the point 6, 10. Since they both crossed at that point. We have the point 10, 6. And the point down here we have 10, 0. So we need to check each one of those to see which one might work to give us our maximum profits. And again, our z function is 12x plus 40y. So let's start with the very top one, 0, 6. I'm sorry. Should be 0, 12 because we counted by 2's. All right, so let's try it. So 12 times 0 plus 40 times 12. That would be 0 plus 480. So a total of $480 profit. Let's continue on. Let's do 12 times 6 plus 40 times 10. So 72 plus 400 equals 472. So not quite as much as the other one. Let's do 10 and 6. So 12 times 10 plus 40 times 6. 120 plus 240 equals 360. So we're losing profit. And then finally, the bottom right-hand corner, 12 times 10 plus 40 times 0 will give us a $100 profit, $120 profit. So our maximum profit is here, meaning our maximum profit is $480 with 12 pigs and no goats. Certain animals in a rescue shelter must have at least 30 grams of protein and at least 20 grams of fat per feeding period. These nutrients come from food A, which costs 18 cents per unit and supplies 2 grams of protein, 4 grams of fat, and food B, which costs 12 cents per unit and has 6 grams of protein and 12 grams of fat. Food B is bought under a long-term contract requiring that at least 2 units of B be used per serving. Another contract requires the amount of food B used be no more than 3 times the amount of food A. How much of each food must be bought to produce the minimum cost per serving? So this time, instead of looking for maximum, we're looking for minimum. So looking for the minimum cost. So it looks like it costs 18 cents per food A and 12 cents per food B. We don't know how many units of each we have, so we're just going to classify them as X and Y. We do know that food A has 2 grams of protein and 4 grams of fat, and food B has 6 grams of protein and 2 grams of fat. But we know that we don't want anything less than 30 grams of protein, so we want more than 30 grams of protein, and we want more than 20 grams of fat per feeding. And we have a long-term contract. And we're going to get to that here in a second. So we know that 2x plus 6y has to be greater than or equal to 30 for a protein. 4x plus 2y has to be greater than or equal to 20. And if we look at our service contract, it says food B is bought under a long-term contract requiring that at least 2 units of B be used per serving. So y has to be greater than or equal to 2. At the same time, food B used B more than 3 times the amount of food A. So it can't be any more than 3 times the amount of food A. Our Z function is going to be 18 cents by how many food A we have, plus 12 cents food B. We're also going to constrict this to the first quadrant. Of course, we can have negative grams of protein or negative grams of fat. So keep in mind that we're going to use the first quadrant because we want y to be greater than or equal to 0 and x to be greater than or equal to 0. So let's transform these equations so that we can start graphing them. So we start with 2x plus 6y is greater than or equal to 30. So 6y is greater than or equal to negative 2x plus 30. Divide by 6. So y is greater than or equal to negative 1/3 x plus 5. So here's one graph. We also had 4x plus 2y is greater than or equal to 20. So 2y is greater than or equal to negative 4x plus 20. Divide by 2. So y is greater than or equal to negative 2x plus 10. We also had the constriction of y is greater than 2 and y is less than or equal to 3x. So we have 4 items that we need to graph. Our y-intercepts are pretty small, so we'll leave our scale the same. Okay, so let's start with y is greater than or equal to negative 1/3 x plus 5. So we go up to positive 5, and then we need to drop down and go over 3. And we'll create a nice straight line. And it looks like we want our graph to be on the top side of this since it's greater than. Next, let's graph y is greater than or equal to negative 2x plus 10. So we'll go up to 10. And we'll go down 2 to the right 1. Again, another nice straight line. We have to graph y is greater than or equal to 2. So again, when we have y equals a number, it's a horizontal line at that number. And again, we want bigger than that. So far we're kind of in the top right area. And we want y is less than or equal to 3x. So if I graph 0, to get to my next point, I go up 3 over 1. Up 3 over 1. And I create this nice straight line. And we want numbers less than that. So the area in which we're concerned about, taking into consideration where everything is shaded and where they would overlap, is this area here. So we have some points that we have to check. The points that we have to check are here. We have to check 2, 6. We have to check here. 3, 4 is another turning point, and we have to check here. Oops, 9, 2. So we have 3 places because we're looking for the minimum with our z function. So our z function was 18 cents times x plus 12 cents times y. So let's check 2, 6. So 18 times 2 plus 12 cents times 6. Using our calculator, we would get 36 cents plus 72 cents for a total of $1.08. Okay, let's check the bottom point there. So 18 times 3 plus 12 cents times 4. That would give us 54 cents plus 48 cents for a total of $1.02. So it's cheaper yet going that route. And then finally checking the far right point, we have 18 cents times 9 plus 12 cents times 2. So $1.62 plus 24 cents equals $1.88. So that would be too much. So the one that works is the $1.02. So our minimum, just to kind of state, our minimum of $1.02 was used with 3 grams of protein. Since our x value is 3 and x results with we don't want 3 grams of protein. I don't know why I said that. We want 3 grams of food A, and we want 4 grams of food B. 3 represented our x represented food A, 4 represented our y value, and y represents our food B. And this concludes section 3.3, Applications of Linear Programming.